Hey everybody, this is Larry. This is me going over Q4 of the weekly contest 320, number of beautiful partitions. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. So this is just to be clear, this is a very hard problem. Very hard dynamic programming. It's gettable, but you have to be very experienced, or at least moderately experienced with dynamic programming, so that you can kind of figure out how things, how things come along, right? Because there are some pieces that you can explore and get to the answer, but having a core understanding of dynamic programming is required to kind of get it within contest time anyway, right? Meaning that maybe conceptually you could get it in like a few hours, but to get it in contest time, you need to have explored it already in the past, or not this one, but like something similar. Let's kind of get into it a little bit. So just some retro for me is some retro for me is I actually made a silly mistake. I actually, for some reason, I didn't realize that there was a K and a min length. So I kind of solved the problem like in a really weird way. If you watched the live solve portion of it in the beginning, but obviously I eventually did get it in about 17 minutes. A little bit on the slower side, but I'm actually okay with it because I was very deliberate about just getting it right. But I think the part about that is that I was initially very confused because I thought that without the K, because I think I missed the K part, which is the big part. Without the K is actually pretty straightforward, and I was kind of confused as to what. I was kind of just confused about what the problem was about, like. Or maybe not, phrased a little bit differently. I was just confused about why no one solved it like really quickly. Because if there was no K, I almost want to say like, mentally I was like, okay, there's this difficulty level for this problem if there's no K, and that, in my mind, obviously some people got it very quickly anyway, but what I mean is that in my mind, I'll be like, okay, I expect certain people or certain number of people to be able to solve it within a few minutes, given that case, right? And I see that a lot of people more are doing that silly cheating trick. I don't know. It is what it is, I suppose, including this guy. I not gonna lie, I don't really, I'm beginning to not respect these people, but that's fine. It's up to them. But they probably submit every time anyway, but it still feels like, what are you doing? Anyway, because I always submit every time, no matter what. I don't care about my rating. But anyway, So that being said, so what I was sorry about the rant, but what I was saying there is that I was like, okay, I think so. Initially, I just didn't understand why people didn't get it quickly, and then halfway through, I was like, oh, there's a K, and or maybe more than halfway through, and you see it in the live portion. But let's kind of solve this without the K first, right? And then we'll kind of think about it. So, and we'll go over the code in that without the K. So first of all, I just set this up. I don't know if this is the cleanest way to do it. And of course, I sang the mod song so that I don't forget the mod. Then here I kind of I wouldn't call this cheating, but it just kind of make sure that we don't do any work if this is not true, so that because the last number has to be a non-prime and the first number has to be a prime. So I just want to make sure that this is the case, because if not, then we can skip all the work, right? And then here, so the thing that I noticed was that and I don't know that this is a needed optimization. I kind of did it. I did it just, I don't know. I did it. But basically the idea is that if you create a partition, by definition, let's just say we have this one, right? Let's just say we have this one. By definition, if you create a partition, it has to be, that means that the first number has to be a prime and the last number has to be not prime, right? Because that's just how this problem is set up. So basically here, what I did is that I set up places that I can potentially have the partition, meaning that if this is not a prime and the number next to it is a prime, then I add a possible place of partition. And I also add it for 0 and n, so you could kind of think of it as the one in the beginning and one at the end, right? So okay, and so I am going to let me see if I can do. So I'm going to rewrite this a little bit first, right? So yeah, so for j is in range of from I, right? So then if right, something like that. And actually technically you don't, because that would just be wrong. So you have something like this. So I lied about the k part a little bit, but without the k part, then you can just skip this part and it'll be just I and j. And the I wanted to bring out the I and j part first because this is of course just the number of paths going from A to B, right? Given a DAG, this is the number of paths. So let me actually bring up the drawing real quick. Because basically, as we said, now we have some. Oh, I have to put it on screen. So you can think about it as, let's just say, I don't know. I'm not going to actually write out. Okay, fine. I'll write out the numbers. But 3, 1, 2, 3, 1, 4. I don't know, whatever, right? And then dot dot dot. So then you can think about it as places for partition here. Not all of them are actually valid, so I'm going to delete them. I forget what the rows are again. But let's just say I think this is one. Maybe this is one. So basically, the idea is that you have and of course this is a function of min length, right? Because if min length is 2, then this is an edge. If min length is 3, then this is not an edge because there's only 2 things within, and this is an edge, right? And so forth. But let's just say that looks like this, and then of course now that you have this, it just becomes the number of paths going from either the first node to the last node or last node to the first node, depending on how you structure it, right? And this is a very common problem in dynamic programming, so you definitely should get used to it. And that becomes n squared. And this is basically what this code does, right? Ignoring the k dimension for now. So that's basically like for each I, you look at, okay, is this the minimum length? Meaning, is there an edge from I to j? If there is, then you just count add the number of paths to you just add the number of paths from that node to the current place. So what happens when you add in k? Well, k is now a dimension because we wanted to make sure that we have exactly k parts. So then here the answer becomes okay. So the dynamic programming question is for count sub. So before, if you don't have a k, count sub I is equal to the number of paths going from 0 to I, or something like this, right? At least that's the way that I structured it. And adding k is, and you could kind of watch me solve it during the contest because I did it this way, and now it's like, oh wait, there's a k, and then you can see me add k. So this is authentic, but I kind of did it in a weird way. But k sub I is equal to number of paths going from 0 to I with exactly k partitions. So that's basically the only difference. And the difference here is that if you add a partition, so there's an edge, so you want to use this edge, you go to k minus 1 partitions to go, because the transition is from k to 1 partitions to k partitions. So that's basically the idea here, right? Okay, let's say you believe in all this stuff for now, and then now what? Well, now we maybe do a little bit of analysis, and this is why I didn't submit it. But and if I was a little bit careless, maybe I would. I noticed that n is equal to 1,000 and k is equal to 1,000 at the worst case. So I guess technically it's not possible, but even like 1,000 squared times 500 over 2 or something like that, it's gonna be too big, right? And here you can, I mean, these are just for loops, so you can see it, right? So it's k times n, right, in the worst case. And therefore, this is going to be too big, 1,000 cube, say. Or even 500 cube is too big, but, this is too big, right? TLDR, too big. So how do you solve this now that you see this? So the idea here is it's kind of, and this is why when you watch me solve this, actually, during the next portion, you actually see me writing this 3 for loops out just so that I can kind of visualize it. But the idea, the trick, and this is maybe a little bit tricky to see, but the idea here is that what am I doing, right? What is this? So, well, the thing that I'm trying to do, and this comes with experience and kind of playing around the function, and knowing that you can, or maybe that you can do it and try it, is that, well, let's see if we could get rid of one of the loops. If you get rid of one of the loops, this will become 1,000 square, and maybe this would be good, right? So that's basically what we're trying to do. And the one that I took a look at was this one, right? Because what am I doing? Basically, what if you write it out in function, right? This the count of k sub I is equal to the sum of count of k minus 1 j for j is less than I, but also for some and p sub, whatever, right? The condition that we have here, right? So that's basically the entire thing. So here, from now, the next step is to figure out, well, when you look at this, you notice that this, as I gets bigger, what happens? As I gets bigger, as I gets bigger, obviously counts the sum total, this entire function also gets bigger, right? But you can also write it in a different way, right? Because you can, because we're dealing with counts here, so it's going to be monotonically increasing-ish. I know that is under mod, so it's technically not true, but you know what I mean. But basically here is another way to write this is maybe just something like, I don't know. And maybe there's an, I think there's actually a cleaner way of writing this too. Now that I just saw it, I didn't do it during the contest, so maybe that's why some people got it so quickly. But the way that I did it is that this is equal to this. How would I even say it? Sorry, friends, I have to think about this a little bit. But the idea here is that almost like it creeps up, right? Meaning that as I gets bigger, you keep track of j and then gets bigger from it. There's actually a different way of doing it now that I think about it, but I didn't do it that way. And I'm going to show you this code as to what I mean. So this is my code. After kind of taking out that loop, basically the idea, and everything else is the same, so it's just this part. The idea here is that we start with j, and almost like a 2 pointers algorithm now, right? Meaning that as j, every time we increase I, that's basically what the for loop is doing, right? It increases I plus 1. Every time we increase I, we go, okay, for this j, how much more do we add to the j, right? Because everything else, the sum from count of k minus 1, sub k minus 1 to the previous j, well, that doesn't change, right? And that's why we have this current, because this doesn't change as I gets bigger, except for you need to add in the pieces in the middle. So that's basically the idea. Yeah. One more thing, so that's basically the idea, and then now, with this new algorithm, you can see that this is going to be n squared because, this is 2 pointersy, so each j will only get hit once. So this is just like 2 times n, and this is n. So in total, this is going to be O of n squared, or n times k, I guess, but k can be n, so n squared, right? And that's going to be fast enough. Yeah, that's pretty much all. That's about 80%, or that's 95% of what I have about this poem. So one thing that I did just notice now that I'm talking about it in this video is that you can actually be a little bit more clever, because this is actually, because I think another way of writing this, if I was, I mean, and there, in a lot of graph problems, a lot of problems are similar, right? So this could actually also just be k is equal to I is equal to count of k minus I minus 1, because this number, represents, this is the number of the sum up to j, right? So then now, and then if you do, and then now maybe you could, you know, do something like this, and then something like this, and then yeah, count of, and then you just add the j's on. So maybe this is a little bit cleaner way of thinking about it. It's going to be the same, but I leave it up to you. And of course, you have to make sure you remember the mod and all this stuff. But that's going to be roughly the same. Yeah, I just kind of, yeah, the way that I thought about it is kind of, yeah. Especially since now that I think about it, now that I see this, k sub I doesn't actually, k sub I is exactly current. So actually, I guess we do it that way because count of k sub I is 0, right? This actually doesn't do anything. I just realized this now. Okay, so today we both learned some stuff. Anyway, this is pretty much it. 31 lines of code. Yeah. So the complexity, like I said, it's going to be n times k, n square-ish. The space is also going to be n times k here. But one more thing, if you want to do a space optimization, and I do have a video on dynamic programming progression to the space progression part, you can actually reduce the k part of the space so that you can actually reduce this to O of n using, you know, because almost like a Fibonacci thing, you only need the last two arrays, so it's going to be O of n space. So you only need O of n space in that case if you want to, you know, if you want to further optimize. Cool. That's pretty much all I have for this one. Let me know what you think. Let me put this here just for fun. That's all I have. So yeah, let me know what you think. Stay good. Well, actually, what I was going to say is you could watch me solve it live in the contest now. So please, no timeout. I didn't look at the, okay. Should look, I mean, it's linear, but Leetcode Python has been always confusing for me. Okay. How am I doing? Just kind of give a rough estimate. People are already very done, so that people are very fast. Wow, people are very fast on Q2. I took a very long time. Maybe you could have just done this. I guess you could do it as part of the recursion. I don't know. Anyway, oh, what's a beautiful recursion? A partition. K not okay. N is 1000, so no 2 to the n case in case. I was wondering min length is 2. Okay. Oh, each substring starts with a prime digit and ends with a 9 prime digit. Okay. Okay, mod. Prime digits are 2. Okay, fine. Okay, fine. I don't even know if they're good, but okay. And the rest of the digits are 9 prime. So that's pretty much it, huh? So that's going to be n square. Is that fast enough in Python? Poop. That's why people got this one so fast. I think this one is way fasterable. I need to kind of figure out how to do this quickly. Yeah. Oops, that's not true. So basically, okay. If if so it has to start with a prime and nonce with a non-prime. So if good of 0 okay, because that's just an impossible case, might as well speed that up. Otherwise okay, the hard part is kind of partition points. Okay, fine. So so actually we could do better than that, I think. Better than this actually. So let's actually delete this for now. So we want to if R sub I is not good, and I should have called it prime, I don't know what I said. Okay, and then oh, this min length, I missed this actually. For some reason I saw 2 and I just assumed everything is 2. Okay, fine. So min length could be 1 though, I guess it doesn't make sense. So okay, so there's no shortcut then, because up for 2 I think there's a closed form maybe, but now maybe not so much. So okay. So this is this true? So let's say this is 2, and this is going to put 0, 1. So now we want this. I guess this is okay. If P of J, P of I minus P of J is length. It may be off by 1 though, to be honest, so I have to be careful here. Count of do they have a big case, or do they just not? 311 is so terrible, but I got it wrong anyway, so. Did I mess this up? Why is this not printing anything? Maybe it terminated early? Oh, this is wrong. If not good, and if this is a prime at the end, then it doesn't fit. Oh, this is fine. This is length for P. Also this 422. That's not quite right. 0479. 0 is fine. 4 seems fine. 7 is fine. 9 it seems fine. So what is the wrong answer here? Oh, I have to do one more for the very end, don't I? Okay. I think now this is right, but clearly I'm doing something wrong. This should be a pretty straightforward one though, so this is a little bit sad. Maybe not. Maybe people are just way whatever about it. Let's see, 04 was the minimum length 2. So they all fit. Why is 5131 not right? Or like just go this and then 5131. Okay, it's to be 3. Wow, I missed that totally. Wow, okay, let's go back then. Wow, I am an idiot. Did I do this wrong then? Wow, I missed that totally. Whoops. Because then now this is an N cube type thing. That's why it's hard. Okay. I mean, there's a way to do it with sliding windows, but that's tough. Because that's a tough DP though. I mean, I know how to do it, but I can see why this is not that easy. But basically, this is use sliding window here instead, which is tough. Okay, fine. Okay, let's write out the expensive one first. Oh wow, I messed up some stuff here. Okay. I mean, this is doable. You could do it, Larry. Focus. Yeah, okay. Now you want the K in here. It doesn't really matter though. Is it partitions maybe? Okay. Part is on the outside. Okay, fine. Fine. Okay, let's just check that this is right first. That's what I want to do. Yeah, okay, this should be 1. Let's index our range. Okay, so this is right, but this is going to be too slow for sure. The idea here is that okay, I mean, this is right. Okay, focus, Larry. Well, a lot of people are very smart about this one. But okay. So, how do I do it again? So then P sub I and J. How do I do it? Okay. So the sliding window is such that, okay. So first, while P sub this has to be outside. So while P sub I minus P sub J, so J is equal to 0. So okay, let me think about this one. So if this is true, we increment, and by definition of the I, then it should be 0, so that shouldn't be okay. But that also means that current we add by count of k minus 1j. So this doesn't make sense to be here. Maybe we have to do it here. But this looks really awkward. Okay. Of course, I don't want to take any risk. And also, if this fails in Python, I'm going to be so upset because this is mostly right. Okay, so that's the push. That makes sense. It's only I was thinking about the pop part, but I guess it doesn't actually do the pop part. Okay, well that didn't work well. K minus 1j. Okay, so okay, no, I think I'm doing this wrong. So it does order I, but then now j. Okay, so this has to be a little bit different. Maybe it's up here and I just kind of confused it. But this part is a little bit tricky. Do I do k first? Does that work? Maybe if I do k first, that makes sense. I don't know that I can do this, to be honest, but okay, so it doesn't do anything really. Why doesn't this work though? Oh, I am dumb, that's why. Because this should be current. Okay. Might as well try one more case. That's good, right? I forget which one is supposed to do first. Okay, 3, 1, 3, 1. It's 10, 20, 24, 70, 80, 90, 100. Okay, that was very fast, but also very 1,000 pieces is probably too long. Okay, let's just say 100. Yeah, that looks okay, fast enough. Let's give it a submit. Hopefully I'm right. Fingers crossed. Yes. Okay. Obviously, hit the like button, hit the subscribe button, join me on Discord. Let me know what you think. Thanks for watching. And yeah, stay good, stay healthy, to good mental health. Hope you did hope you had a great contest and had a good time at this prom. I'll see you later. Bye bye.